Hello GATE aspirants, welcome to part 6 of GATE Quantum Mechanics series. Question number 12. The Pauli matrices for 3 spin-half particles are sigma 1, sigma 2 and sigma 3 respectively. The dimensions of Hilbert space required to define an operator O is equal to sigma 1 dot sigma 2 cross sigma 3 is. Now each spin-half particle is described by a 2-dimensional Hilbert space. So if we have n particles, then dimension will be 2 raised to n. Here n is equal to 3, so this will be 2 raised to 3, that is 8. So answer is 8. Next question. Let L bar and P bar be the angular and linear momentum operators respectively for a particle. The commutator Lx Py gives. So commutator Lx Py is equal to Lx is equal to R bar cross P bar. So this will be y Pz minus Z Py Py. This is equal to ypz py minus zpy py. This will be equal to y py. This we can separate. So this will be y py. Then we have pz plus y pz py minus zpy py and minus z will be outside first, then z py py. This is equal to 0, this is equal to 0 and this is also equal to 0. So we have commutator ypy which is equal to I h cut and into pz. So answer is option C I h cut, option D I h cut pz. Next question. An operator for a spin-half particle is given by A bar is equal to lambda sigma bar dot B bar, where B bar is given and sigma denotes Pauli matrices and lambda is a constant. The eigenvalues of A are. So A is equal to lambda sigma dot B. So that is sigma x Px plus sigma y By plus sigma z Bz. This is equal to lambda. Sigma x is 0, 1, 1, 0. By is b by root 2 plus sigma y is 0 minus I 0 into by is b by root 2 and bz is 0. So last term will be 0. So this is equal to lambda b by root 2 into we have 0, 1 minus I, 1 plus I, 0. Now we can find out eigenvalues using this relation A minus lambda I is equal to 0. So we already have this lambda here. So let us use lambda dash. So this is equal to 0 minus lambda dash. Then we have 1 minus I into lambda b by root 2. Here 1 plus I into lambda b by root 2 and 0 minus lambda dash. This is equal to 0. So minus lambda dash into minus lambda dash, that is lambda dash square, is equal to minus 1 plus I, 1 minus I, lambda b square upon root 2 into root 2 is 2. This is equal to 0. So lambda dash square is equal to, this will be 1 plus I, 1 minus I, that is 2 into lambda b square upon 2. So 2 and 2 will cancel out. So lambda dash will be plus minus lambda b. So here option B is correct. Next question. Consider a system of 8 non-interacting identical quantum particles of spin 3 by 2 in one-dimensional box of length L. The minimum excitation energy of the system in the units of pi square h cut square upon twice ml square is. A particle is 3 by 2 having spin 3 by 2. So degeneracy will be G is equal to 2s plus 1. So that is 2 into 3 by 2 plus 1 which is equal to 4. So each state will have 4 particles. It can contain maximum of 4 particles. For minimum excitation state energy, we have to find out ground state energy and first excited energy. So Eg will be, now 4 particles can be in ground state and next 4 particles will be in second state. So this will be equal to 4 into pi square h cut square upon twice ml square into n square, so this will be 1 square, plus 4 into pi square h cut square upon twice ml square into 2 square. So here we have 4 particles in ground state, that is n is equal to 1 state, and 4 particles in n is equal to 2 state. And this is equal to 16 plus 4, that is 20 pi square h cut square upon twice ml square. Next, for first excited state, this will be in n is equal to 1 state, we will have 4 particles, then n is equal to 2 state, 3 particles, and n is equal to 3 state, 1 particle. So this is equal to 4 into pi square h cut square upon twice ml square into 1 square, plus 3 into pi square h cut square upon twice ml square into 2 square, plus 1 into pi square h cut square upon twice ml square into 3 square. And this is equal to 4 plus 12 plus 9 into pi square h cut square upon twice ml square. 12 plus 4 plus 9 is 25 pi square h cut square upon twice ml square. So minimum excitation energy is equal to energy of first excited state minus ground state energy. So that is 25 minus 20, so 5 pi square h cut square upon twice ml square. So answer is 5. Next question. A particle is confined in a box of length L as shown below. If the potential V0 is treated as perturbation, including the first order correction, the ground state energy is. Now ground state energy for a particle confined in a box is h cut square pi square upon twice ml square into n square. So first term will be this only, and it is same in all the options, so we have to find out first order correction only. So E01 is equal to psi, then that perturbating function into psi 1. Now psi of x for a particle trapped in one dimensional box is under root 2 by L, then sine of n pi x by L, n pi x upon width, which is L here. So if we put n is equal to 1, we will have just sine pi x by L. Now this perturbating potential is only in this region, otherwise it is 0. So this E01 is equal to square of this, so that is 2 by L, and this is from L to 0 to L by 2, then V0 into sine square pi x by L, and in the region L by 2 to L, this V is equal to 0, and we have here psi 1x square, and that is 0 only, so we don't have to consider it. So 0 to L by 2 dx. V0 is a constant, so this will be 2 V0 by L, and integration sine square pi x. So this can be written as 1 by 2 into 1 minus cos of 2 pi x by L, integration from 0 to L by 2 dx. So this is equal to 2 V0 by L, 1 by 2 common, so this will be x minus sine of 2 pi x by L into L by 2 pi, and limits are from 0 to L by 2. So 2 and 2 will cancel, V0 by L, then L by 2 minus 0, so L by 2 minus, if we put L by 2 here, then this will be, this will be 0 only, sine 0 is 0, and if you put L by 2 also here, then it will be 0 only. So V0 by L into L by 2, which is equal to V0 by 2. So here option D is correct. It is plus, so V0 plus V0 by 2. Next question. Suppose a linear harmonic oscillator of frequency omega and mass m is in this state at t is equal to 0, where psi 0 and psi 1 are the ground and first excited states respectively. Then the value of psi x psi in the units of under root h cut by m omega at t is equal to 0 is. Now x cap, operator x cap is under root h cut by twice m omega a plus a dagger. and psi is given to us. So psi x psi is equal to under root h cut by twice m omega. First we will have psi a psi and plus psi a dagger psi, and this we have to solve. Now if a is operated on psi n, then this gives under root n and psi n minus 1. So basically these are ladder operators, so raising and lowering operators. So psi n, this will be under root n plus 1 and psi n plus 1. So if we operate a on psi and psi is this, then 1 by root 2 is constant only, and then psi 0 will be, so you cannot lower this, so this term will not be there, and psi 1 will be psi 0. So this will be e raised to I pi by 2, and this will be psi 0. And if a dagger is operated on psi, this will be plus 1. So 1 by root 2, then psi 0, so it will be 1, so psi 1 plus e raised to I pi by 2, and 1 will be 2, so under root 2 into psi 2. Now we will substitute it here. So this will be equal to under root h cut by twice m omega. Now a operated on psi is this, and we have we will write bra psi here. So that is equal to 1 by root 2 bra of psi 0 plus e raised to minus I pi by 2 and psi 1. So we have only psi 0 term here, so that will come. So here psi 0 is 1 by root 2, 1 by root 2. So this will be 1 by root 2, 1 by root 2 e raised to I pi by 2 plus. For the second term we have here psi 1 and psi 2, but psi 2 term is absent here, so only psi 1 term we have to consider. And for psi 1 term we have here 1 by root 2, then 1 by root 2 and e raised to minus I pi by 2. Now we have to solve this. So operator expectation value of x is equal to under root h cut twice m omega. 1 by root 2 into 1 by root 2 is 1 by 2, and e raised to I pi by 2 plus e raised to minus I pi by 2 upon 2. And this is cos pi by 2, so under root h cut by twice m omega into cos pi by 2, but cos pi by 2 is 0, so answer is 0. So this will be 0, answer is 0. Next question. Let the Hamiltonian for spin half particles of equal masses m, momenta p1 and p2, and position r1 and r2, h is given, where sigma 1, sigma 2 denote the corresponding Pauli matrices. H cut omega is 0.1 electron volt and k is 0.2 electron volt. If the ground state has net spin 0, then the energy is. First we have to calculate this value. Now if we write sigma is equal to sigma 1 plus sigma 2, because we have two particles, so sigma square will be sigma 1 square plus sigma 2 square plus 2 sigma 1 sigma 2. So sigma 1 dot sigma 2 is equal to sigma square minus sigma 1 square minus sigma 2 square upon 2. But sigma square is 0 and sigma 1 square is 3i and sigma 2 square is also 3i upon 2. So this is equal to minus 3 only. So now energy is equal to energy, this is a harmonic oscillator, so energy will be n plus half h cut omega, so this will be 2 into, this will be 3 by 2 h cut omega plus we have k into this sigma 1 dot sigma 2, this is minus 3. which we have calculated now. So this will be equal to 3 h cut omega plus k into minus 3. So 3 into h cut omega is 0.1 electron volt plus k is 0.2 electron volt into minus 3. So that is 0.3 minus 0.6, so minus 0.3 electron volt. So answer is 0.3. So these were all the questions from GATE 2015 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.